Welcome, everyone. Today, I would like to discuss the difference between average speed and constant speed, and then focus a little bit on what velocity is a little bit later in part two of this video, all right, on motion. All right, so what is motion? Motion is things that are moving, all right, things that travel a certain distance over a certain time. And as we get further into this video, we will look at the formula for speed, which is distance divided by time. We're also going to discuss what the main difference between speed and velocity is. We're also going to look at what the difference between average speed and constant speed is. I think a lot of times when we think of speed, we think of athletes, we think of cars, trucks, but speed is anything that moves over a certain amount of time, whether it's animals, cheetahs, what we consider to be the fastest animal on the planet, turtles, what we consider to be the slowest or one of the slowest, all right, species on the planet. They can still travel at a certain speed. Speed is anything above zero. Okay. And in one of my other videos, we talked a little bit about what relative motion was. All things are relative. Yeah, we can compare humans to ants, humans to speeding cars, but is it relative? We know what's faster. We know what's slower. But as long as an object is moving over a certain amount of time, it has speed. In this slide is just a quick little graphic organizer going over the three formulas that we are going to focus on during this unit with speed, and that is also distance and time. All right, we need all three variables in order to calculate all of the three of them. Speed, distance divided by time. Some common units of measurements. We have kilometers per hour, miles per hour, which we are very familiar with. It's the one we use here in the United States. We got meters per second, kilometers per second. I mean, we could come up with many more as long as it is a distance unit of measurement with a time unit of measurement. Calculating distance. We need the following two. We need speed and time. So we need to know how fast the object's going and how much time it did it in. And then we would be able to calculate how far it went. Some common units of measurements that we're going to use: kilometers, miles, meters, maybe even centimeters or millimeters. And then lastly, time. In order to calculate the time an object is traveling, we need to know the distance and the speed at which it travels. Okay, and some common units of measurements for time that we'll be using is hours, seconds, and minutes. Okay. All right. So what is average speed? All right. We just said the formula for speed is distance divided by time. So the formula for average speed, okay, is still distance divided by time, but it's going to be the total distance divided by the total time. Okay. So let's take a look at this graph. Here it is a distance time graph. All right, you see the distance over here, the time here, and the blue line represents the speed at which the walkers are traveling in their walkathon. All right, so if I want to know what the average speed was for the walker in this walkathon, I would take the total distance, okay, the total distance here, all right, that the walker walked was 90 meters, and I would divide it by the total time it took that walker to walk the 90 meters, which was 9 minutes. Okay, so if I want to know what the average speed by this walker in the walkathon, all right, I would take the 90 meters, divide it by the 9 minutes, and that would give me an average speed of 10 meters per minute. So this walker was walking 10 meters in a minute, okay, or every minute. All right, so now when I look at this graph, there's a ton of information here. All right, we can calculate speed at every meter that they walked, every minute that they walked, every second that they walked. And what we also notice is that, the blue line that we see at the beginning of this race, all right, we see an increasing slope, we see a flat line, and then we see a curved line. All right. Like I said, a lot of information. All right, so let's take a look at what the average speed for the first 3 minutes of this race was. All right, so I look at my time down here, 3 minutes. All right, so we're looking at this straight diagonal line. All right, that's increasing. All right, so what was the average speed here at the 3 minute mark? Okay, well, at 3 minutes, this walker walked 60 meters in 3 minutes. So 60 divided by 3 gives me 20 meters per minute. So in the first 3 minutes of the race, they were averaging a pace of 20 meters per minute. But if we look at the entire race, it was 10 meters per minute. So why the difference? Well, most of us at the beginning of a race have more energy, probably come out a little bit more faster. All right, so the first 3 minutes, all right, the walker averaged a pace of 20 meters per minute. All right, what was the average speed for the first 4 minutes? So now we got our 3 minutes, all right, and our 4 minute mark. So what was the average speed? Well, let's look at the distance. At 4 minutes, the walker was still at the 60 meter mark. All right, represented by that dot there. All right, so what was the average speed after 4 minutes? All right, 60 meters divided by 4 minutes gives us an average speed of 15 meters per minute. Well, after 3 minutes, it was 20 meters per minute. Now, after 4 minutes, my speed went down. It decreased. All right, why? Well, right here, between the third and the fourth minute, we see a flat line. At the third minute, the walker was at the 60 meter mark. At the fourth minute, the walker was still at the 60 meter mark. So what does that tell you? It means they stopped. Maybe they took a water break, or maybe they just were tired. Okay, but in a race, we know the time doesn't stop. Okay, we can stop our movement, but the time won't stop until we finish the race. Okay, so this is why the average speed decreased a little bit, all right, from the third to the fourth minute, because the person had stopped moving. All right, so question 4. What was the average speed between the third minute and the 6th minute? Okay, right here. All right, we see a flat line. So at the third minute, we're at 60 meters. At the 6th minute, we were still at 60 meters. All right, so our total distance in this time was 0. Okay, so that's what I would put for my total distance. 0 divided by the total time. Well, the total time between the third and the 6th minute, 6 minus 3 gives me 3 minutes. So my average speed between the third and the 6th minute, 0 divided by 3, is 0 meters per minute. So for this 3 minute period of time, the runner did not go anywhere. Okay, so the average speed here in this portion of the graph was 0. So we can basically figure out what the speed of this walker was at any point on this graph, any point on that blue line, as long as you take a look at the distance and you take a look at the time. All right, look at the first minute. 20 meters divided by 1 minute. How fast are they going here? 20 meters per minute. 20 divided by 1. Okay, average speed. All right, constant speed. All right, when something's constant, it means it doesn't change. Speed that doesn't change, that's constant speed. Okay, if we look at this graph, all right, we see that any point on this line, okay, it's a straight diagonal line. Okay, straight diagonal line. At any point on this line, we should get the same number. So let's look at this first point. We got 10 meters divided by 1 second. So the average speed after 1 second was 10 meters per second. After the second, all right, we were at the 20 meter mark. 20 divided by 2 is also 10. Let's climb up a little further. 40 meters divided by 4 seconds. 40 divided by 4, 10. So a straight diagonal line represents constant speed. Okay. All right. So where would constant speed be needed? Well, one thing I could think of, all right, is driving a car. Cruise control. All right. One of the features in all cars nowadays, all right, is cruise control, where you get up to a certain speed, you hit the button, and it stays at that speed until you brake or you accelerate to change that speed. I happen to like that feature, especially when I'm traveling on highways, across the states. All right. Um, it saves on gas because I'm not constantly stepping on the accelerator. All right. And things like that. So, constant speed, you set it at a certain miles per hour. All right. And it stays there unless you brake or accelerate. Okay. All right. Another benefit. Okay. How about this? We could all use one of these during this distance learning period. All right. A treadmill desk. All right. I wish I had one of these. Here the worker is working on his computer. All right. And probably traveling at a constant speed of maybe 1 or 2 miles an hour. Depends on what he sets it at. So you get some health benefits here. He not only can work, but he can also exercise while he works. All right. And for those that may go to a gym or have a treadmill at home, you know that you can set treadmills at constant speed. Whether you're walking or running, you want to set it at 8 miles an hour, it's going to stay at 8 miles an hour until you change the speed. Okay. So until then, it will remain constant. In the next video, we will discuss what velocity is, and we will go over some problems to calculate for distance, speed, and time.